Is everybody cool with what's happening right now? Okay. Did I get all the inflection points up there yet? So all you got to do, this is too nice to believe, all you got to do is start the way it's supposed to start, meaning, of course, I'm increasing first, right? I'm increasing and I am concave down initially. And then as you hit each point, you see what's changing. So I'm increasing and I'm concave down initially like this. That's an inflection point. Oh man, I got to come in a little steeper. All right. That's an inflection point, so now I'm supposed to turn and become concave up. And then that's going to be another inflection point. So now I'm concave up. Does everybody see what's happening? So it is, people will get upset at me on a test when they have something like this, and I circle that and take points off. Well, yeah, it's not supposed to be concave up there, is it? No. See, so that is going to be a part of what I grade now, of course, because that's a freaking mess of calculus. That's the part I'm grading. Get right. All right. So that's concave down, changes to concave up because that's an inflection point. That's another inflection point. This is off. You see what I'm saying? And now, so I make it concave down in between these things. Wee-ah! Another inflection point, so now I make the concave up. Another inflection point, so now I make the concave down. Now, if you really wanted to, you could plug 3 and negative 3 in there to see where that is, but, whoa, haven't done enough work for that. So that's really beautiful. I mean, the calculus is actually not horrible. Be careful with the factoring stuff. And then this step is just labeling them, starting correctly and then changing. If you hit a min, you know you're going to turn around. If you hit an inflection point, you know you're going to change the concavity shape, right? I mean, that's, if you label them, you know what to do as you hit them. And you can always graph the damn thing before you do it so you know what it's supposed to look like. Just be really careful about that. And this is what I meant before. If you do something wrong here, I want to see that wrong thing reflected on your graph. Well, if you thought it was concave up in here, I want to see you doing some weird shit. And, you know, if you thought it was concave up in here, you might try to do something like that. And I'd give you more points for that because you are translating what you see through calculus. You're translating it visually. I don't want to see the right answer with the wrong work. That means you didn't really do it. Is anybody with me there? It always sounds a little weird when you first hear it, but he wants to see wrong work. No. All right, do you want to take a break now, or do you want to? Let me do this. Let me give you this sheet right now, and then we'll take a break. I want to give you this sheet officially, talk about it for a second, and then we'll take a break. So somebody had a really good question about what would a problem look like on a test. Basically exactly like this. Right, notice how, on number 1, what's the domain of number 1? Oh, real numbers, a stupid little polynomial. I'm not even going to ask. On number 2 on the back, oh yes, that one's a little more involved, right? So that's where I want to find the domain so that I know, like if the domain is x greater than 3, then every little sign diagram is going to have a hard wall at 3 and not giving a shit about stuff below it because I only care about stuff above it. I mean, that's why you want to figure out the domain first, because it's going to affect what you do in these steps. Okay, so let's take a break. If you want to, you can start doing some of this. Let's come back at, what, 5, 10, 15, 20? 5 till. Come back 5 till.